just jump in here and solve some problems. The big thing is just be aware of the rules and don't make up your own rules. That's what tends to happen in math class, right? Like we just make up our own things that aren't true. When you see addition or subtraction of logarithms, you want to use the property that I taught you yesterday. When I see addition, right away I think, can I put those logs together back as multiplication? Yes. So I could write this as log 5 of x plus 6 times x plus 2 equals 1. And now you have options. One option is we could rewrite this using the definition of a logarithm. The other option is you can undo a log by raising it to the base power. So you see how this is log base 5? If you wanted to, you could 5 both sides. That's my own made-up language, and that really means nothing outside of this classroom. But just like we can e both sides to get rid of ln, right, you can take it to the power here. So if you wanted to here, you could write a really big 5, and like it raises everything up as the exponent, and that's using that inverse. Because if you say 5 log of 5, that cancels out, and you're just left with this, which I'm going to go ahead and FOIL out if you're okay with that, x squared plus 6x plus 2x plus 12. And over here, I get 5 to the first, which is just 5. That's exactly what you would get if you would rewrite it using the definition of a logarithm. You'd say 5 to the first equals that. But it's just another way to think about it. So your goal is to get rid of the log or the e or the ln, and then you still have to solve the problem. Which means on this one, is it okay if I subtract the 5 over and get a x squared plus 8x plus 7?
Yep.
Then that's our favorite quadratic. You can either factor, complete the square, do the quadratic formula. I think this one's factorable. Is that true? You get 7 times 1 gives you 7 plus 1. So you get x equals negative 7, x equals negative 1. But you need to be very careful because remember that you cannot take the log of 0, you cannot take the log of a negative number. So when you solve an equation that has logs in it at the beginning, you've got to make sure that your answers don't give you a negative log. So if I took negative 7 and I plugged that in here, would I get the log of a negative number? I cannot have the log of a negative number, so you have to exclude that answer. What about negative 1? If I plug negative 1 in there, does that keep it positive? If they both gave you negative answers, you would have to say there's no solution to this problem. But negative 1 does give me a positive answer, so that one works. Courtney?
What would you do if it like works for one to another?
If it makes any of them negative, you exclude it. So even if this would have been like x plus 8, because this one made it negative, you would still have to exclude it. Other questions about that? Maybe next time not to give the candy cane out to the end of class. What do you want to do on this? Both are true, but you can't e it until you have 1 ln equal to 1 ln. Alright, so you can't e it until we do the property first. So I'm going to say that's ln of x plus 6 over x minus 4, because subtraction goes to division. And really you have two options here. You could e both sides, because if you e both sides, they cancel out. But if you just have an ln equal to an ln, like, they just cancel out. So either way works here, as long as you realize that you can just write this as x equals x plus 6 over x minus 4. Now the hard part is, what do I do to solve this? Multiply by x minus 4. And I get x squared minus 4x equals x plus 6. Another quadratic. So if I subtract 1x over, that's going to be minus 5x minus 6. Is that one factorable? Multiplies give you 6, subtracts give you 5. Yeah, be really careful on that, because 2 plus 3 gives you 5. But since we're subtracting, you have to pick 6 and 1, and be negative 6, positive 1. So x equals 6, x equals negative 1. Why we spend so much time in Algebra 1, Algebra 2, pre-calculus, and this class in the beginning talking about quadratics, because they just show up everywhere. Do I have to exclude either one of those answers? -1 is not going to work up there. It makes that one negative. So 6 would be my only answer. Yeah, like the ones you can solve by the quadratic formula, putting the square. What about this one? We actually did one of these a couple sections ago, but yeah, we could for both sides, just for it, we like to say. Just to it. 2 is my favorite one because you can say just to it, like just do it. This morning on Facebook, there was an ad. It really creeps me out on Facebook that they give you ads that, like, they know what to give you ads for. Like, they always give me ads for math shirts. And how do they know that I would buy math shirts? But Facebook knows me, and it's creepy. But today there was an ad for an ugly Christmas sweater that had math on it, and I was like, oh my gosh, I have to order the sweater. But I'm afraid it's not going to come before Christmas, so I didn't order it.
No, you can join the order it. If anything, you can use it for Christmases.
Like your phone. Location services, where I showed you, it can tell you when you've all been.
Yeah, it's creepy. It's Big Brother watching you. Miss Bai is super paranoid about Big Brother. Well, about Mr. Puckett being Big Brother, because she thinks there's microphones, like, listening to everything we say all the time. Like, yesterday she wanted to tell me something secretive, and she's like, let's go outside, because I can't let anyone else hear this. So we had to go outside the building for her to tell me, because she was sure that there were microphones listening to her. Well, there is a microphone recording me right now, but she thinks, like, everywhere that they're listening. But yes, we can for this, and you would get x equals 4 squared. Also, just to throw it out here, back a couple sections ago, before we just for'd it, you could also rewrite this using the definition of an exponent, which would give you the same answer, right? You could rewrite this as 4 to the second equals x, which is exactly what you get there. Same thing, same amount of work, really, whatever makes most sense to you. But that's just 16. Right, that one was easy. We did that one first. Anyway, I might order the sweater anyway, and if it doesn't come this year, I'll just have it for next year.
Yeah, jump on the Mr.
It's on some weird website because, like, they won't ship it until December 9th because, like, it says in the terms, like, even if you order it, if they didn't sell, like, their goal, then they won't charge you because they're not going to give them to anyone if they didn't sell their goal amounts. But they've already met their goal, so it's for sure I would get it, but they won't ship any until the last day to order, which is December 9th, and then they'll ship them after that. They are. Like, they're not going to make it if they're not going to make money, I guess. Like, they're not going to make the sweaters if they don't make money. But it said December 9th, and then it said 7 to 14 days before I would get it. So, I probably would get it. But still, I was pretty excited about it. I sent a picture to my husband and said, can I order this? And he's like, if you want. I'm like, it's a math ugly Christmas sweater. Of course I want it. And then he was like, why are you even asking me? Why would you ask me permission to order it? And I was like, I don't know. I'll just order it. Trying to pretend that you had a say in the things.
What's your husband? What's his life career?
He works at IU West Hospital. He's a clinical engineer is his job title, but like they do all the preventive maintenance on anything, and they fix stuff when it breaks, like the sterilizers. They sterilize all the equipment for surgery, and the CT machines, and all that stuff, ultrasounds. So he makes pretty good money. He makes more money than I make, so which isn't saying much. But
I still am trying to work
he used to work. He used to work at Kroger. That's where we met at Kroger.
I know. Just because you were still when you told me the story about you guys met at Kroger, so I just always think he's like a friend.
We worked at Kroger together. He was a butcher at Kroger.
That's one day. I'd be a butcher for a while. Anyways,
What?
I wouldn't want to do a light bulb.
I think he would, but I really want to do
He doesn't want to talk to you. He's kind of a shy guy. He's very opposite of me.
That's already something we have in common.
His worst class ever in college was speech. Like he hated speech because he can't. He's very shy about speaking.
You're just kind of like goofy style, like.
Aaron, what should I do on this problem.
Alright, you're gonna take. Can I just teach this one? Just hand me the marker. Let me work this out.
I will, prove it. Just go take the force.
No, sit down.
Don't grab it. Rip it out of our hands. Grab it.
I'm gonna go ahead and say, oh wait, what do you want to do? Do we want to move this 9 that's divided by, or we want to just say what log 3 of 9 is?
Divide it. You want to divide it.
Okay, you're killing me.
I said that.
Go sit down. Eat your candy. You see what I'm saying about what is log 3 of 9? Just saying, you could have just said it was 2 and then moved it over, but that's okay. Now what do we want to do? 3 it? So this cancels out, and I get x plus 4 squared over 9 equals 9. And I get x plus 4 squared equals 81. Let's think about our options here. One option, we could actually FOIL this out. We could subtract 81. We could do a whole bunch of crap. But what would be a better option? Yeah, let's square root both sides first. You get the same answer if you FOIL it out right, but I think this is a better option. But don't forget, Jake, what do we have to do on this side?
Oh gosh.
Plus or minus.
I totally forgot that too.
Hoping if I remind you enough, you won't forget again. He forgot plus or minus on his calc test a few times, and it added up to lots of points. So we get negative 4 plus or minus 9. Actually, give me the two answers. Negative 4 plus 9 is 5. Negative 4 minus 9 is negative 13. You have to throw one out. Can I have negative 13? No.
Oh, why?
Negative 13 plus 4.
Just kidding.
I think I know how I'm gonna buy it. Yeah, every teacher makes a mistake here. I know who I'm gonna buy that. I would try that per cane. $1.
And then it's for Interact Club.
Do they have other flavors or are they all just?
Sometimes she has different flavors.
I just think it's crazy because you can like go buy a box of them for like.
Because you're donating money. That's what
Yeah,
it's for.
it's not about it. It's about.
It goes to the Interact Club, and then Interact Club does different things. They make some no-sew blankets. They
They make
send letters to people. I don't know what else they do, but
Can we get anonymous?
I'm super jealous.
they can be anonymous. But if you write something bad on it, Miss Vi reads all the things. If you write something that seems inappropriate or bullying, she rips your note off.
Did you hear about the one that Joey Baxter got? Someone sent him one and it said, "I'm sorry, I'll sit with you at lunch tomorrow, XOXO." And then he's just like, "It's just a module and tell us about it." Except it wasn't sit, it was set. And so they thought it was a person that I'm not gonna name. But
Grady got the same one.
really?
Grady got one that says, "I'll seat with you at lunch."
Yeah.
But it's spelled S-E-A-T. Maybe it's just a joke. Maybe someone just playing a meme. Maybe it's a bullying thing. That's the trouble with these little things is
Let me
people
tell you.
break the
Macy
rules.
Chambers is definitely worth $1.
Whoa.
Oh, God.
Hey, yo.
This
This class just got a lot.
I don't even know what that means. So,
It's
oh, okay. I'm like, I'm out of the loop. I don't know.
I'm so happy that she just got that on the microphone.
I forgot that was I forgot that was
Hey, you know. Yeah, I tell it now.
Send her a link to the video.
Right there.
Right, Nick.
What grade is your sister in?
She's a freshman. Thanks for it.
Okay,
How old is she?
stop.
Love knows no age.
But the law does.
First of all, that's only like 4 years.
Well, but if he's 18 and she's 14, that's against the law.
They can still date.
Yeah, we can date.
They can still be in love. They can still have deep love.
Olivia's gonna watch this and just be so annoyed. She's gonna come back tomorrow and just be so mad. Angel will just laugh. I feel Olivia will be angry. Okay. On these problems, make sure if it says give exact answer and answer to 3 decimal places that you're not using your calculator till the very end. But it's the same idea. Addition goes to multiplication, so I can say that this is x times x plus 2. What the heck's going on with my parentheses? Equals 4. Oh man, this is crazy. I forgot how terrible this is.
Is it seriously bad? Like, that's... Or do you eat it?
Because then I'm going to e it. And I'm going to go and distribute and say that that's x squared plus 2x equals e to the 4th. Which is just a number, but don't type it in your calculator yet. Because I don't want a decimal yet. So this is a quadratic, right? Can I subtract e to the 4th over here? Is that factorable?
No. You gotta do the quadratic.
You gotta do the quadratic formula. Or we can complete the square. Maybe complete the square won't be as bad. Let's move it back over. Let's leave our spot and let's move e to the 4th back over here. That might be better. Boys, focus. If I complete the square here, what would I put right here? Half of 2 is 1 and 1 squared is 1. If I add 1 here, I add 1 over here too. Oh, that's way better than the quadratic formula. And then I'm going to stop talking about it. Aaron. Stop being stop. Still kind of ugly because we have to square root this.
Wait, why would you square root that?
Because I gotta get rid of the square. Do I need to put plus or minus on this? Can I plug a negative into an ln? So I'm going to just take the positive root of e to the 4th plus 1. And then I'm going to subtract 1. So I get the square root of e to the 4th plus 1, and then minus 1 out here as my answer. Barf. Then I can type it in my calculator. Square root of e to the 4th. Make sure you close the parenthesis after the 4. Plus 1. Close the parenthesis for your square root. Minus 1. And you get 6.456. That's exciting. And I still got more to do. I should have done number 6 first because it's way easier than number 5. But what would you do on this problem? If we did some of these before that we could rewrite as the same base, so I would like 2 to the x and then 2 to the what equals 10, nothing, right? Like you can't rewrite that one. But what could we do to this so that maybe we could pull that x out front? Does anybody remember how we did these in the past classes? Yeah, if I had a log or an ln in there, then I could use that property that we're allowed to bring those x's out front. I like ln, but ln or log base 10, either one would work. I don't know why I like ln, I think just because it's shorter to write. But if I ln both sides here, I'm allowed to do that. That lets me use the property, or log both sides, that I can pull that x out front. And if I can get that x out front, then now this is a pretty simple problem to do, that I can just divide both sides by ln of 2. And again, if they want an exact answer, this would be your exact answer. ln of 10 divided by ln of 2. And no, that is not ln of 5. You're not allowed to divide these numbers. And then you would type that on your calculator. Make sure that you put parentheses around the 10 there. And that's about 3.322 as your answer. That idea comes up a lot in the story problems. And so if you have a story problem where there's an x or a t or whatever in the exponent, and you're trying to solve it, you're going to have to ln both sides or log both sides. And so I put a couple story problems on there. There's a couple story problems on your homework. There's definitely a couple story problems on your unit test. Sometimes it's as easy as just plugging it in on your calculator and sometimes you gotta solve it. And so I think I gave you parts A and B to show you. Read the problem, figure out what you're trying to find. Maybe it's simple, maybe you gotta do a little bit of work. The resident population of the United States in 2008 was 304 million people and was growing at a rate of 9% per year. Assuming that this growth rate continues, the model, so they give you this equation, notice it's an exponential equation, 304 1.009 to the t minus 2008 power, represents the population in millions of people in year t. So they tell you the equation, they tell you P represents the population, and the year is T. According to this model, when will the population be 354 million people? Where should I plug this number in? For P or for T? That's my population. And since the population is already in millions of people, should I plug in 354 or should I plug in 354 million? Right, they've already said the answer's in millions. So really A and B are the same on here. We might just do A on this. It's the same problem. They just changed this one to 416. But I could set this equal to 354 equals 304 times 1.009 to the t minus 2008. And what would be the first step we should do in that problem? Divide the 304 over. Do you agree with that statement? I cannot multiply these two together because one has an exponent. You can leave it as 354 divided by 304. You can reduce it. If you write it as a decimal, write a lot of decimal points. Do not round until the very end, which means I would say if you're going to write decimals, write a minimum of 6 decimals, and then at the end you can round. When I do this, I tend to just leave it. Like I don't even simplify. I just say 354 divided by 304. If you divide it, it's like 1.164473684. Like I would probably write all those decimals now. Does it reduce very nicely? I don't even ever worry about it. Yeah, but still not very pretty. So it doesn't matter. However you want to leave it. But then every time you do a problem like this, if you're trying to solve for what's in the exponent, what are you going to have to do to both sides? ln it or log it. I don't care. I don't know why I like ln so much, but I do. I think because I can squish it in there like that. And I like to make cursive L's like that. Some little things in life that make me happy. Again, up to you on how you want to do this. I don't use my calculator till the very end. So I'm going to leave this as ln of 354 divided by 304. And on this side, I know I can pull that t minus 2008 out because of the ln. It gets a little messy if we don't use our calculator till the end, so that's why I'm okay if you just write all the decimals. Think you're going to be a decimal person? You're going to write it all down as you go? I don't know. There's a lot of stuff we're going to have to do over here. But to solve this for t, what else do I need to do to get t by itself now? I could divide by ln of 1.009. That takes care of this. And then what else would I need to do? I'm going to have to add 2008. So I think my final answer would be ln of 354 divided by 304 divided by ln of 1.009. And then I'm going to add 2008. And that should give me a year that makes sense. It's okay to use decimals as you go, but again, use lots of decimals. This isn't that bad to plug in. You just got to be careful with your parentheses. 354 divided by 304. Close your parenthesis. Divided by ln of 1.009. Close your parenthesis. And then add 2008. I get an answer of 2024.999 if I rounded 3 decimals, which means at the very, very end of 2024, or you could round that up and say at about 2025, or you could be real fancy and change .999 to months and days and all that stuff. But definitely the end of 2024. If you would have got an answer smaller than 2008, that's not a reasonable answer because we know the population started at this much in 2008. And so that's where you can kind of look at the reasonableness of your answer. I'm not going to do part B on this one because it's the same thing except for we would change 354 to 416. Are you with me on that? Questions about that? Look at the last one here. There's one on your homework just like this. The value V of a Honda Civic DX that is T years old can be modeled by this equation. 16,775 times 0.905T. Again, I think it's important to see the two types of questions they can ask. Part A says, according to this model, what will the value of the Honda Civic be after 3 years? Where would I plug 3 into this problem? T, which means this is not an LN problem. You're just going to plug 3 in here, and you're just going to use your calculator. And you're going to say 16,775 times 0.905 to the third power. And there's probably a good chance that there's going to be a question on your test that is as simple as that you just have to read the problem and figure out where to plug it in. And we're talking about money here, so it would make sense to round to like the nearest cent. $12,433.93. But look about part B. Part B is kind of like what we just did. It says, when will the car be worth $4,000? So now you're trying to solve for T. So just like the last problem, now you're going to set it equal to 4,000. Only it's not as complicated as the last one. And you're going to have to divide by the 16,000, LN both sides, divide it over, and you should get a time in years. And again, see if your answer makes sense to the problem when you're doing this. Again, I'm kind of lazy on these in that I just leave it like that. But if you wanted like a simpler fraction or you wanted a decimal, you could do that. I simplified mine on the calculator. I just hit the fraction button with that, and it simplified to 160 over 671. Or if you want to write the decimal out, you can. But you gotta know to get rid of that t, you have to either log or ln. That's going to be a big part. If you don't do that, you're probably going to miss a lot of points. So I get the ln of 160 over 671 equals t times the ln of 0.905. And then I'm just going to divide that over. And then it's definitely a calculator heavy problem. Close your parenthesis after the top part. And I got about 14.36 years. Unless you wreck the car before then, and then it might be worth less after that, right? That's it. That's Unit 4. Today's really just practicing solving those problems, and you know that that's going to show up on the exam. This is the homework that I'm giving you, and you notice on 98 and 100, those are the story problems. You only have to do part A. Tomorrow we'll go over this, maybe have a homework quiz, and then I'm going to give you the review assignment. And then Monday, we'll go over the review assignment. Tuesday and Wednesday, we'll take our Unit 4 exam. And that leaves Thursday, Friday, Monday, Tuesday, Wednesday to review. So, yeah. Yes. 2 and 6 on Wednesday, 1, 3, and 5 on Thursday.